Hello guys, let me share with you our next project, which is going to be 1-point linear perspective. So we're basically going to be drawing three-dimensional looking images using what's called linear perspective. And to simplify that a little bit, we're going to put a vanishing point in the middle of our paper, draw the face of an object, connect it to the vanishing point, and it'll look three-dimensional. So even in that description, I used a lot of vocabulary. So let's slow down and really look at how we use this system. So one of the things I said you may not be familiar with is I'm saying linear perspective. The word linear is actually, I think, a word that you can really familiarize yourself with. It means line, linear, line, L-I-N-E. And it means to draw with lines. So if something's really linear, it's drawn with lines. Perspective has a lot of meanings, and we're going to just use to perceive depth. So what we're going to do is for linear perspective, we're going to use lines to create the illusion of depth, to be able to perceive depth on a flat sheet of paper. So this is an example of a linear perspective drawing. Perspective is really a fantastic system, and you can spend a lifetime exploring it. And it's a system just like math is. And I say that because it's a system that can get more and more complex. So if you reflect on your education of math starting in kindergarten or first grade, you learn addition, and then that's really great, but it has its limitations. And then you learn subtraction. Suddenly you can add and subtract. And that takes you pretty far, but then you discover there's multiplication. It continues to get more and more complex, calculus, and then even beyond calculus. Perspective is similar. In perspective, you can learn 1-point perspective. That's what we're going to study. We're going to study 1-point perspective, and that's the drawings we're going to do. And it's a very good system. There is a next step. There's 2-point perspective, which gives you more views, 3-point perspective, multi-point perspective. There's even false vanishing points. So I do just want to let you know we're going to learn a system, and it has its positives, but also its limitations, just like addition. Addition is a powerful system, but it's got its limitations. So let's move on to the 3 vocabulary words that we'll be using for our drawings. There's vanishing point, orthogonal, and face of an object. The vanishing point is the point in a drawing where lines seem to recede to, or to use the word in the term, they seem to vanish to in a picture. So it's this point that seems where everything seems to recede or vanish to. Orthogonal is the line that goes to the vanishing point. We talked that these are going to be linear pictures. We're going to use lines, and these lines have a name. They're called orthogonals. So to build on something you already know, you probably already know the word horizontal. So a horizontal line. There's a vertical line. There's a diagonal line. And now this is perhaps a 4th term for the way to describe a line. An orthogonal is just a line that goes to the dot. And then our last term is going to be the face of an object. It's the flat surface or face of an object. I think where you might be familiar with this is we might say the face of a clock, like a clock face. And we know what we're talking about. We're talking about, it's oftentimes that circle where the numbers from 12 go around. And so that's the face of an object. And so we'll just be talking about the face of an object. That is different than the human face. So it's the face of an object. So vanishing point, orthogonal in face of an object. So just to keep kind of getting familiar with this, so here's a picture of a railroad track. And what you might be able to see is there's all these lines in it, and it looks like they're vanishing to a point right here. So we know that these railroad tracks in the real world probably run parallel. But when we see lines that our brain knows should be parallel, and we see them converge together into a point, we see that as creating depth. And so these lines, this linear image, begins to have the perspective of depth. Here's another photograph of a railroad track where we've used computer lines to help you see that. This blue dot would be our vanishing point. Everything seems to be vanishing. We're using lines, so it's linear. And all these lines would be orthogonals. We use the term orthogonals because it's more specific. All these lines go to the vanishing point. Whether that line is a diagonal, this line vanishes, it's a diagonal, or a horizontal line can vanish to the vanishing point. So all of these lines are orthogonals. And it really is how we see the world. We can't truly experience depth, right? Like I don't internalize it. Somehow my eyeball has to get this information to my brain, and it does it in a flat way, and it sees depth. So do you see how this is a real world object, but this black object way off in the distance could be my vanishing point? I could use lines, linear, to vanish towards there. And those lines could be diagonals, they could be horizontals, or verticals. So that's why I use the word orthogonal. It's a line that goes to this dot. Here's sort of a perspective drawing, again showing everything is vanishing to here. But now what the artist does is the artist has included a few shapes. And we're going to call these shapes the face of an object. Here's the face of this coal railroad car. Here's the face of the building. And the sides vanish to the distance. And again, just one more example of how it really is how we see things in the real world. Here's a photograph. And then an artist has used a computer just to kind of roughly turn it into a line drawing. And really boldly, they've used lines, linear, to show how these objects vanish to a common vanishing point. So again, here's that city. And our mind doesn't quite fully recognize, but the side of the building's all pinching down towards a vanishing point. So let's take it in a simple drawing. Vanishing point. I put a single dot in the paper and I'm having objects vanish. I draw the face of an object. So this is somewhat like a square. And then I connect the corners using orthogonals, just lines that vanish off to the distance. So again, face of an object, and then I'm going to use orthogonals to go to the dot. The orthogonal always has to vanish to the vanishing point. Face of an object, I'm going to draw orthogonals. I'm going to draw another face of an object. So here's a face of an object. And I'm going to connect the corners to the vanishing point. So those are orthogonals. And look here at this lower part. Even though I've stopped it when it hits this object, the line does line up to the vanishing point. The orthogonal does go to the vanishing point. And so that's the same thing that happens. Here's a face of an object. I've used a ruler to connect that. I've connected that. And so you can see how this system is used in paintings. You could actually imagine that there's a point here and that this road vanishes to the vanishing point. There's an orthogonal. This system's used a lot in really simple computer games because it's a very simple, almost mathematical system. You do a dot and you program that every line is an orthogonal vanishing to the vanishing point, whether that orthogonal is a diagonal or a horizontal or even a vertical. And so the system can just keep on building. So 1 point perspective.